That was good. Microphone.
I'm head of Baldwin Astrophysical Observatory, and the first project is connected with CCD sky survey of carbon stars. The observation material of whole projects of the Baldwin Astrophysical Observatory is obtained by Baldwin Schmidt type telescope building at 1964 at Zeiss factory. It is the 12th largest Schmidt type telescope in the world to this time. The outstanding quality of the mirror and correction plate allows to reach 22 magnitude faint objects. At the orbit of main asteroid belt, it mean about object with a diameter 50 meters. The other outstanding characteristic of the telescope is the wide field focal plane. It means that the image of the telescope covers 19 square degrees of the sky in the photographic frame and 2 square degrees in the CCD frame. Telescope also is installed by 4-degree objective prism, which gives a low spectral resolution, about 500. What was this? Why not go to... carbon stars. The typical carbon star has a mass in the interval 1 to 9 solar masses. The stars has an oxygen-carbon core. The carbon to oxygen ratio is greater than 1. Therefore, in the spectrum of stars, dominant carbon compounds molecular bands. Carbon stars are displayed on a asymptotic giant branch in the Hertzsprung-Russell diagram. In the central part of carbon stars dominate triple alpha fusion. Fusion in the hydrogen fusion shell. Time to time, we observe helium flashes, and therefore we have carbon stars. Carbon stars are very interesting peculiar astrophysical objects which differ from the ordinary red giant, so-called M stars or oxygen giants, for which carbon to oxygen is smaller than 1. On average, on 40 oxygen star giant, we have only 1 carbon giant star. The investigation of carbon stars in our galaxy has been unevenly explored in different parts of the galaxy. This was shown by analysis of the Catalogue of carbon stars, which compiled by Baldwin Astrophysical Observatory astronomers. To obtain homogeneous sample of carbon stars, it is a task of this project, and it is convenient to use an infrared 2-micron sky surveys, and we have see that this indexes for carbon stars is more greater than for M stars. Based on this criterion, we have a list of potential carbon stars, but of course this list need to checking. observational materials has been gradually acquired since 2006. The potential list of carbon stars contains more than 20,000 objects. Therefore, the program of the observation was planned to cover 5 degrees delta slices in each season of observation, beginning from the pole and gradually descend to the celestial equator. For carbon stars, Cyagan and Swan carbon molecules is a stronger band heads which we can see in the spectrum of carbon stars. And this is a typical details which allow to these carbon stars selected from the M giant stars. More than to view of carbon stars is clearly differs. Then we can see here one carbon star, and here we can see typical M stars, and therefore we can check this list of potential carbon stars. More than 700 CCD covers cover in this observation period Cassiopeia, Perseus, Auriga, Cygnus, Cepheus, and Pegasus constellations. 49 new carbon stars we discovered, and 347 bright standard stars also observed in this period to study the spectral characteristic of this object. The distances is a great enigma of this object. Only of some brighter carbon stars are possible to measure parallaxes. The Mauron studied the carbon stars in the Large Magellanic Cloud, and he showed that carbon stars have that distribution in this Large Magellanic Cloud, and late carbon stars, as we see, have vary the absolute magnitudes in very small interval, and depends on the G minus K colors indices. It allows to us create a methodology to obtain the distances of fine carbon stars of our galaxy. Of course, taking into account interstellar absorption, which we obtain from the near-infrared observation of dust distribution in our galaxy. The Baldone distances are compared with the Gaia satellite parallax measurements, and here we can see this correlation, and probability of this correlation is about 81%. Our discovered 49 carbon stars displaced on the galaxy plane, and we can see that these carbon stars only very weakly tied to the galaxy arms. No, it is a normally, but because this is a late stars, it is a fact practically possible to the future of our sun, but about after 2 million years. The second project of observatory is a connect with the observation of asteroids, which was carried out within the project of Latvian Council of Science, Complex Investigation of Solar System Small Bodies. In this project, which started in the autumn of 2018, in 221 observation lines, we obtained more than 5,000 CCD images, covered more than 600 square degrees of sky, and whole measurements of astrometric position of 1,122 asteroids were published at Minor Planet Center. And in this period, we discovered 49 new asteroids. Without this, more than 3,000 CCD images devoted to the study of the photometric characteristics of 25 NEO-type objects. And there we have the table which have these asteroids, and this is a continuous this table, and now we continue the photometric data reductions, but for 7 of asteroids we can obtain the periods, as we can see here. For the other, the data reductions are continuing. At first, when we determine the period, we check the standard stars, because from these measurements depend the quality of measurements of asteroids, and only after we obtain the period of asteroid. If the period is very easy, then it is not problem. But when period is greater, then we use Fourier analysis to detect the best size of period, as for Stolte.
Ilgmārs, 5 minutes.
Laiks, yeah.
Mazāk kā 5 minutes.
Yeah. At the end of the I said some words about the publicity. Due to the establishment of the planetarium in the 2012, many publications and conference reports, the publicity of Astrophysical Observatory has grown significantly. In 2018, the observatory was invited to Erasmus Plus project online observatory, and in 2020, observatory became the member of the International Asteroid Warning Network. The third project was Erasmus Plus project, which started also at autumn of 2018. The online observatory was founded by 5 observatories: Baldone, Broadfer Observatory Denmark, Harestad Observatory Norway, Helsinki Observatory, and Finland Falks Telescope Project. And it is a United Kingdom observatories project. This project is devoted to the education purposes in astronomy. Project outcomes are 71 education activities for the teachers and students of all ages. And here is an online observatory link where is these outcomes for education for publicity. Thank you, the 2 micron of Sky Survey and Gaia data, and also the Latvian Council of Science, and thank you for the attention.
Thank you very much, Ilgmārs. It's really nice presentation and a very informative one. Only a few very short questions if suddenly somebody wants to ask. Okay, then we're closing our session.